Hi, today we are going to focus on different types of organic reactions. The drawing of the reaction mechanism will be covered in other lessons. Organic reactions are classified in two ways. The first classification is by what happens when the reaction is over, which could be substitution, addition, elimination, oxidation, reduction, condensation, or rearrangement. For substitution and addition, the second classification is also used in conjunction. This classification is by the reagents, which include nucleophile, electrophile, or free radical. So we could have, for example, nucleophilic substitution, nucleophilic addition, electrophilic substitution, electrophilic addition, or free radical substitution. To fully name an organic reaction, particularly for addition and substitution reactions, we first need to identify the substrate and the reagent present. A substrate is the reagent that provides carbon to the new bond. In other words, substrate is a chemical species which react with reagent to give corresponding products. The other reactant which bring about this change is called reagent. Apart from the product of interest, some other products are usually formed in organic reaction. These are called byproducts. In the following reaction, the carbon in the new bond is provided by methane. Therefore, methane is the substrate and the chlorine is the reagent. The product of interest is chloromethane and the byproduct is hydrogen chloride. A substitution reaction happens when an atom or group of atoms of the substrate is replaced by another atom or group of atoms. This reaction is characteristic reactions of saturated compounds, which are organic compounds where all the carbon-carbon bonds are singly bonded to each other. In this example, X is being substituted by a nucleophile, giving two products. Since X is substituted by a nucleophile, this reaction is named nucleophilic substitution. Using a previous example, we will discuss which substitution reaction occurs in this reaction. A hydrogen atom on methane is being replaced by chlorine in the presence of light. Now we know that when chlorine molecule is exposed to UV radiation, it will undergo homolysis or homolytic fission and produces chlorine radicals in the initiation step. Look at these following propagation and termination steps. Chlorine radical reacts with methane to produce methane radical, which in turn reacts with chlorine radical to produce chloromethane. So to be more specific, this reaction is called free radical substitution. In an addition reaction, two molecules combine to give a single product. This is characteristic reaction of compounds with multiple bonds, such as in alkenes or alkynes. In this example, the alkene is the substrate and hydrogen bromide is the reagent. Since the substrate has C double bond C, it acts as a nucleophile and will attack the electrophilic hydrogen on hydrogen bromide. Because an electrophile is being added first to the substrate, the reaction is named electrophilic addition. As seen in the equation, there is only one product produced in addition reactions. Bromination of ethene is another example of electrophilic addition reaction, where the nucleophilic alkene attacks the electrophilic bromine. Just in case you're wondering, the partial charges on bromine molecules are formed through the induced dipole-induced dipole attraction. The elimination reaction is an organic reaction in which two substituents are removed from a molecule to form a new product. The process takes place in the presence of acid, base, metal, and sometimes through heating. This reaction is a method to synthesize unsaturated organic compounds from saturated ones. The elimination reaction is mechanically the reverse of addition reaction. In this example, bromine and hydrogen atoms from adjacent carbons are removed to produce an alkene and hydrogen bromide. Whereas in this reaction, the hydroxy group and hydrogen on adjacent carbons are eliminated to produce cyclohexene and water as the byproduct. Oxidation is a process which involves the loss of hydrogen or gain of oxygen. In this oxidation reaction, methane loses 4 hydrogen and gains 2 oxygen to form carbon dioxide. Primary alcohols can be oxidized to form an aldehyde upon losing hydrogen atoms. The aldehyde will have a lower boiling point than the alcohol because it loses the ability to form hydrogen bonding and can be distilled off. If, however, the alcohol is heated under reflux, the aldehyde does not evaporate off and stay in the reaction vessel, which causes it to become further oxidized to form a carboxylic acid by gaining an oxygen. The presence of carboxylic acid will cause the pH of the reaction mixture to become acidic, which can be tested with a pH indicator. Secondary alcohols are oxidized into ketones. The alcohol loses 2 hydrogen, and together with an oxygen atom, they form water as the byproduct. Ketones do not undergo further oxidation. Reduction is a process which involves the gain of hydrogen and loss of oxygen. It is exactly the opposite of oxidation. In this reaction, propanone gains 2 hydrogen atoms and become propan-2-ol in the presence of a strong oxidizing agent like sodium borohydride. Ethanol here acts as the solvent. Organics redox reactions can also be explained in terms of changes in oxidation states. The conversion of an alcohol to ketone is considered an oxidation because the oxidation number of the carbon increases from 0 to +2. Likewise, the conversion of ketone to an alcohol is a reduction. The conversion of alkane to alkene is an oxidation reaction because the oxidation state of both carbons is increasing, and the reverse reaction would be a reduction. A condensation reaction is a reaction in which two molecules combine to form a single molecule and a small molecule is removed during a condensation reaction. Amino acids are important biological molecules that have an amine functional group on one end of the molecule and carboxylic acid functional group on the other. When two amino acids combine in a condensation reaction, a covalent bond forms between the amine nitrogen and the carboxylic acid carbon of the second amino acid. A molecule of water is then removed as the second product. An esterification is a condensation reaction in which an ester is formed from an alcohol and a carboxylic acid. Esterification is a condensation reaction because a water molecule is produced in the reaction. The reaction is catalyzed by a strong acid, usually concentrated sulfuric acid. When butanoic acid is heated in excess methanol and a few drops of sulfuric acid is added, the ester methyl butanoate is produced. A molecule sometimes undergoes reorganization of its constituent atoms or groups of atoms. Rearrangements can accompany addition, substitution, and elimination reactions if they progress through a carbocation intermediate. Rearrangements results in a new carbocation, which is generally more stable. The new carbocation then undergoes a second reaction to give the final product. So rearrangement reaction is a type of organic reaction where the carbon intermediate of a molecule is rearranged to increase stability and give structural isomer of the original molecule. Often, a substituent moves from one atom to another atom in the same molecule. Here's a typical substitution reaction. We're taking an alkyl halide and adding water. Since it's a tertiary halogenoalkane, once bromine leaves, it will form a tertiary carbocation as an intermediate. As we saw in a previous video, tertiary carbocation is the most stable carbocation due to the positive inductive effect of the alkyl groups. So in this reaction, rearrangement is not necessary. However, if we have a secondary bromoalkane, when bromine leaves, it will produce a secondary carbocation as an intermediate. This is where the C2 hydrogen will rearrange itself to the nearby C3, so now we have a more stable C2 carbocation, which is a tertiary carbocation. This represents a rearrangement reaction, when you see a group move from one carbon to another. Now let's identify the type of different organic reactions. First, figure out the type based on what happens in the reaction. So in this example, one hydrogen atom on methyl group is substituted by a chlorine atom. Next, identify the substrate and the reagent. Since the carbon in the new CCl bond comes from methylbenzene, methylbenzene is the substrate. Now think what is substituting the hydrogen on the methyl group. It's a chlorine radical, which is produced when chlorine is exposed to light. Thus, this reaction is called free radical substitution. In this reaction, our substrate is bromoethane. The bromine on the substrate is substituted by a hydroxy group, which is a nucleophile. So the reaction is called nucleophilic substitution. In this reaction, ethene reacts with hydrogen bromide to give only one product. So this is an addition reaction. This time the substrate is the ethene, which is a nucleophile due to the electron-rich carbon-carbon double bond. Meanwhile, HBr molecule is polarized because there is electronegativity difference between the hydrogen and the bromine atom. Because electron density around the double bond is higher, it will attack the electrophilic hydrogen. Because the first thing added to ethene is an electrophile, the reaction is named electrophilic addition. First, notice in this reaction there is only one product, which means this is also an addition reaction. Now the polar nature of C double bond O makes carbonyl carbon electrophilic in nature. Since the oxygen on alcohol are weak nucleophiles, it will attack the electrophilic carbonyl carbon. Since a nucleophile is being added to the substrate, the reaction is called nucleophilic addition. This reaction requires an acid catalyst since alcohols are weak electrophiles. In this reaction, An ester is converted to alcohol. The ester loses an oxygen, so this is a reduction reaction. Butanol reacts to give butanol by losing two hydrogen atoms. Hence, it's an oxidation reaction. In this last example, the bromine and hydrogen atoms from adjacent carbon are eliminated to produce an alkene. This is an elimination reaction. Thank you for watching and see you next time.